Hopefully you've already read through the math review and completed the problem set. You probably recognize most of what was in those exercises from your high school math. We'll be using all of that material as we move forward in this class. But there's something else that is generally not covered in high school math, and that's summation. Summation is something we'll be using very early on in the course, and in fact, we won't stop using it until the end of the semester. Let's take a quick look at what summation is and how to work with it. The Greek letter sigma, the capital sigma, I should say, indicates summation. A sigma sign tells you to add up whatever values follow it. For example, suppose we have a set of SAT scores, and for some reason we want to add them all together. Maybe we're going to compute a mean or something like that. Each X score represents a value which we can number from 1 to 5. In this example, x1 equals 650, x2 equals 625, etc. The sum of x is simply the sum of all the x values, 1 through 5. The expression on the right here says compute 650 plus 625 plus 500 plus 560 plus 640, and it evaluates to 2,975. Of course, they don't have to be x values. We might want to add up y values, in this case monthly rents. Again, we have 500 plus 376 plus 440, etc. In this example, the value of the expression sigma y is 2,466. What about an expression like this one, the sum of x times y? Suppose we have a data set that looks like this. The expression on the right tells us to multiply x1 and y1, x2 and y2, x3 and y3, etc. And then to add up all the products. The total of these products is 43, so we would say that the sum of x times y equals 43. Here's another one. In this case, we're being asked to multiply the x and y values and then square the products. Again, we'll use the summation table, but add another column, which I've added over here, in which to do the squaring. The sum of x and y squared is 467. Do you notice a pattern here? We do the operation to the right of the summation sign for each value in our data set, and we record the result. Once we've gone through all the values, we add them all together. That sum is our answer. Now it's your turn. How would you solve this one? Well, pause the video and see if you can get it right. The correct answer is 201. Here's another one. Again, pause the video and see if you can figure this one out. The correct answer is 13. Note, however, that this problem is distinct from this one. What do you think the correct value is for this expression? The sum of x over 3. In this case, you would divide each x value by 3 and then sum up all the quotients. The correct answer is 13. Let's do just one more. If the summation is enclosed in parentheses, then of course we do the summation first, and then we do whatever follows that. The sum of all the x values here is 39, and 39 squared is 1,521. So there are three basic takeaways from these examples. The first is that in statistics, when we have a variable, let's call it x, it usually refers to a set of values rather than to an individual value, which is probably what you're used to from high school algebra. In Microsoft Excel, we refer to this set of values as an array. Other data analysis packages may call them vectors. We may not show them explicitly, but each individual value has an associated index. The first value in the array is x1, the second value is x2, the third value x3, etc. The second takeaway is that we perform the operations that follow the summation sign on each value or pair of values in the data set and then record this result. Once we're done, we add up all these results. This addition gives us the result of the summation expression. The third takeaway is really just a guideline about the most efficient way to solve these kinds of problems, and it's simply to make note of this summation table, which we've been working with throughout these examples. Again, it's the best way to stay organized and to avoid any careless mistakes. With these rules about summation and with your review of algebra, that's pretty much all the math you're going to need to worry about in this course. I hope you found this video useful and that you understand what summation is all about now.